Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches, class 6 to students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, electricity. Today we are entering the session number 7. So almost we are coming close to the climax. So already this chapter, the two synopses, first synopsis 2, synopsis 1 and 2, we covered in the 5th test. Right. These two are completed in the 5th test 5 as per the examination schedule. Now we are focusing on synopsis 3 and synopsis 4, which are for test 6, which is on 30th December. So by the time we may get again 5 to 6 classes, if we have completed this, we'll go for the new chapter again. But so far we are in the process of covering synopsis 3 and synopsis 4, followed by the so many worksheets and all, right? So this is our complete picture about the coming test C. So in what we learned in the last 6 sessions, that I'll give in one single glance. You can see what key concepts we covered till today in electricity chapter. We can see on the screen. See there is a beautiful bulb and electric current. Everything is there. Okay. So what we covered till now. First, we learn about what is the history of electricity. The great Thales, the Greek scientist, how he introduced the word electricity. Then we came to know about what are the electric charges, what are the positive charge, negative charge, how they are getting the charges, everything. Then we discussed about what is the method of giving charge, that is electrification. The method of giving charge to a neutral body or neutral atom. That is electrification process we discussed. So that methods also we discuss. What are the methods of electrification? For example, electrification is done by the friction, induction, conduction, and lightening in the nature. These are the 4 methods where we can give charge to a neutral body. Okay, so that we discussed separately in the first session. Then law of electricity. So you all know like charges repels, unlike charges attracts each other. Based on that, a Coulomb proposed the law, which is called Coulomb's inverse square law. So you have the right. So Q1 Q2 by R square is a formula for the Coulomb's inverse square law, which is purely based on the law of electricity. Right. Then we also discuss about what are the electric conductors, insulators, and semiconductors. Right. We discuss about. Then we enter into what are the sources of electricity. So as you know, there are so many sources to produce electricity. So many are there. Some of them are small source, some of them are large source of electricity. In that process, we discussed about what is the cell. You know, cell is a small source of electricity. Battery is the little big source. So like that, there are so many types of cells are there to give the large number of electric current as per our requirement. So along with that, we have the transformers, we have the generators, we have the inverters. All these also comes under the artificial source of electricity. Okay, then we enter into the electric current. Of course, circuit also we discuss electric circuit. So what is exactly the current and the units and all we'll discuss today in deep. Before going for that, we'll discuss mainly about the very important part about electric circuit. So you can see here a diagram. If you see this diagram, so see this diagram. What it contains? It contains source. This is a source. Battery is the source of electricity. Bulb. This is the bulb is the consumer of electricity, which utilizes the current. In between there should be a key. there is one key should be there to switch on and switch off. And this is a wire. All these four when connected, this is called electric circuit. So every electrical appliances in our house are connected through a wire to the switch. Otherwise, when you switch on the switch, how the bulb will glow, how fan will move, how AC will on, how iron box become hot, all this because of the circuit. So just to see the outlines of the circuit before going for the synopsis 4. Already synopsis 3 we discussed in the last session. So these are the topics what we already covered in the earlier classes. Charging by friction, charging by induction, charging by conduction, right? And of course, we discussed about law of electricity and electroscopes also we discussed. To detect the charge, we'll use the electroscope, and then by lighting, which takes place in nature between the clouds. Again, second synopsis to discuss about source of electric current. Various types of cells are there, liquid cells, dry cells, right? All this we'll use in our regular time. Then electric circuit, very, very important, which we will discuss in last class. That is our test 6 syllabus is this only. About electric circuits, synopsis 3 and synopsis 4. So electric circuit already explained. Mainly the components of circuits we'll discuss. What are the main components? Components of electric circuit. So what we'll use in the electric circuit actually, components means. So basically, we require one source. One is, source is a very important. Source is the first component, which may be either cell or battery or generator or anything, source, all source. Second one is consumer of electricity. Means which uses electricity, like bulb, right? Computer, anything you can like, right? AC, fridge, all comes under consumers. Second component. Third component is switch. Is also one of the important component without which you cannot operate the circuit. And finally, wire. Right? These are the 4 important components of electric circuit. When all these 3 are connected through, then we can form a circuit. In our house also, there are a lot of circuits such arranged which are connected to fuse. Fuse controls the entire circuit. Whenever there is a low current or high current, it is controlled by fuse, right? That we discussed in the last class. So whenever there is a flow of current is there, the flow of current, then that is called a closed circuit. Switch on. When you switch on the switch, circuit is closed and current will flow. When you switch off the light switch, there is an open circuit where there is no current flow. That already we discussed in the last session. So we have seen how to connect the bulbs in series, parallel. What is the advantage? Whenever you connect the number of bulbs in series means end to end. Series bulbs you can see, decorative bulbs, where you can find there is a same brightness in all the bulbs. But whenever they are connected in the different way, parallel way, we can find the difference in the brightness. That we can see here by connecting the number of battery cells also. When number of cells connected in series, when number of bulbs connected in series. So what is the consequence? Everything we discussed in the last class. Okay. So that is about the entire thing. That is about third synopsis. So before going for the fourth synopsis, in fourth synopsis, come across some important terminology related to current. So before discussing that, I will share you one video on the circuit of electric current, which is very important for us. So what kind of circuits you can find? So what is exactly the circuit? Everything you can understand by the video.
There's one more thing we need to do now before we begin to solve electric circuits. We need to define what is an electric circuit and what are the components of a circuit. That's what we'll do in this clip. And then we will begin to solve electric circuits. The electric circuit is a pathway for charges to flow.
See the total path.
And there are 3 components. You need a power source or a voltage source, some kind of electric device,
Consumer.
and a switch. Let's look at each in turn. For the voltage source, we use a battery. Now, this is the symbol here that we use, and
Symbol,
this
yeah.
represents actually the first one here, a cell. When you have a single cell, that's the symbol. When you put several of these together, you have what they call a battery. We'll use either in our practice problems. Now,
Here, the represent symbol by one, it is a cell. Combination of two or more cells called battery.
notice that the longer side will be positive and the smaller side is negative. So here's the positive and the negative. And the current only flows in one direction when we use a battery. And so it's called DC current or
Direct current.
direct
Battery current is
current.
direct.
All of that must be memorized. Now, the battery supplies a potential difference. And as I've said before,
So
this is
important
often called an electromotive
that I'll
force
explain you.
or an EMF, and it's given the symbol E as shown. Now, the problem is it sounds like then potential difference is a force, but it isn't. Now, sometimes it is helpful to think of it as a force-like quantity that pushes charge, through the wire, but it is not a force. Now, next we need an electrical device. Now, I've already mentioned before that this converts electrical energy to other forms of energy. Now, what do we mean by this? Well, you might use a light, might be in the circuit as the electrical device. Maybe you'll have some kind of a heater. Maybe you'll have mechanical energy like a motor or a buzzer making sound. But what we do when we use these electrical circuits, we will use a resistor to represent these electric devices. And that's the symbol for the resistance, and it will stand for these devices. Finally, we have the switch, as shown here, a switch. And if it's open, that means the path is broken and the charge will not flow. Now, there are two kinds of circuits, broadly speaking. There's the series circuit, and that means there's only one path for the charge to follow. And the path starts from the positive terminal. We actually have from the positive terminal always to the negative terminal, and notice there's only one path for that charge to follow. Now, when we have this flow of, if you will, positive charge, it's called conventional current. It's the flow of positive charge. Now, we know in truth it's actually electrons that flow. But for historical reasons, we use the flow of positive charge. Everything works out fine. And this is what most university textbooks use. And a parallel circuit has more than one path. The current, again, flows from the positive terminal, comes to the junction, splits up, goes through different paths. There's more than one path to follow. And then it comes back to another junction, and then it'll flow back to the negative terminal. A parallel circuit has more than one path for the current to flow. So you need to know the definition of an electric circuit.
Finally, conclusion you can see.
A path for charges to follow. DC current, it flows in one direction only. Conventional current flows from positive to negative, flow of positive charge. A series circuit, only one path for the charge.
And
Parallel circuit, more than one path for the
Right.
charge.
so that's all about the clear explanation about the circuit. Okay. So with this is about completely about the electric circuit and electric components of electric circuit. Electric circuit contains one electric source, one electric consumer which utilizes the current, one switch and wire. When all these four are connected, you can call them as electric circuit. Okay. So in this electric circuit also, we can have we have to control the flow of electricity, which is the resistance that will come across the next chapter. Okay. So this is the complete. So either you can connect the bulbs or cells in series or in parallel also. Series means positive to negative, negative to positive. Whereas parallel means all positive at one end and all negative at other end. So that will again come across in the next when you are discuss about the resistance in the next class probably, right? Now we have when you enter into the next part, that is synopsis 4. When you enter into the synopsis 4 here, what we can find is we'll come across some important terms to discuss. The first one is electric current. So already they told. So charge, there are two types of currents are there. One, when charge flow from positive to negative or negative to positive. So in this positive to negative, it is called conventional current. Convention. Because as per the convention, current flows from higher potential to lower potential. Where here negative to positive is flow of electrons. It gives the electronic current. Right? Electronic current or electron current. So like that, electric current is of two types. Based on which direction charge is flowing. Whether charge is flowing from positive to negative or negative to positive. That depends on how you are connecting. So if it is from positive to negative, it is called conventional current, because convention higher to lower. And it is a flow of electrons is called electronic current. That is negative to positive. So whenever circuit is closed circuit means there is allowing the flow of electrons, flow of current. Open circuit means switch off. What will happen if the circuit is broken? Broken circuit, no current flows. No current flows condition is open circuit. Current flowing condition is closed circuit. Right? Then when you come to the part of electric current, it's a very important term which we need to discuss in deep. Electric current. So electric current is nothing but flow of charge. So when you discuss about electric current, very first mathematical formula will come electric current. So there is nothing but conventional will consider generally. That is denoted by I. I is equal to Q by T. The rate of flow of charge or flow of charge per unit time is called electric current, where Q is charge and time T. So as we are considering time, we get the word rate. Rate of flow of charge means how fast charge is flowing through a conducting wire is known as electric current. It is given by I is equal to Q by T. So Q is measured in Coulomb. The Coulomb is the name of the scientist, and time is measured in second. Coulomb by second, or it is also measured in standard unit. Again, another scientist name Ampere. Ampere is the unit of electric current. And also there is a meter. There is a device called ammeter. Ammeter used to measure the current in electric circuit. So when you are connecting the circuit, we can connect ammeter also to know how much amount of current we are passing. Right? So electric current is nothing but the rate of flow of charge or flow of charge per unit time. That is I is equal to Q by T. That is charge by time. That is Coulomb by second or ampere. And it is measured in measured by ammeter. See, there are two types of currents are there. One is called DC, other is called AC. So DC is nothing but battery current, current from the battery or cell. Direct current, that is unidirectional current. But whereas AC current, which we are using at home, this comes through meter or a transformer, that is two directional current. So in this case, both electrons and positive charge also will flow in opposite directions to give the alternative current. Direct current, alternating current. Direct current is by battery, alternate current by the power source, where you are taking from the transformers. Okay. So this is the first term in the electricity when you are knowing about the electric current chapter. Now when you move to the next slide here, we have some more thing to discuss. about the components only, giving explanation. What is electric bulb? You know, you all know what is electric bulb, right? So bulb is an electric component which produces the light and heat when you pass the electric current. So what the bulb contains also given here, right? The wire will be there. There is a connection, copper wire, terminal, and insulating material here to avoid the shocking. And filament is there. Filament is generally made up of tungsten. This tungsten only will become red in color when you pass the current. So whenever these two terminals are connected to the holder, we can allow the bulb to glow. Okay. Then another component is electric switch. Very important component. So switch, what will do? It make or break the circuit. Right? To make or break means either if you want switch on or switch off. For that purpose, switch is required. Without switch, we cannot operate the circuit. It's very important. Suppose, imagine in your house there are no switches. What happens? The fan will continuously move for the 24 hours a day. Automatically, you get a very big bill. So whenever it does not require, we'll save energy by switch off. Same thing in school also. Those save energies are very important. For our future, we have to save energy. If you are there, let the current to glow. If you are not there, switch off the current. Right? So that helps us to make or break the circuit. That is the reason we use the keys. If there is no requirement, we won't use that many keys in any domestic or commercial purpose, because we have to save the energy for our future, next generations. So switch is the one of the important component of the electric circuit. Okay. So these are the two components. One is a consumer, other is a control. Already source we have seen about the cells, batteries. Okay. Now more explanation is there. Okay. So about the electric current continuation. So already I told SI unit is charge by time, coulomb by second, or ampere, denoted by A. Current is said to be 1 ampere if the charge of 1 coulomb passes through in a 1 second. So ampere is the unit of the current. Similarly, smallest unit if you want. Small current if you want, you can use the milliamperes also. Milli means 10 power minus 3. Right? Mega amperes, large one. Okay. So this is flow of current. How the current will flow in the metal wires. Current always flows from the conductors only. So there you can see. So it implies these many electrons will be there in 1 coulomb of charge. 1 coulomb of charge contains 6.25 into 10 power 18 number of electrons. If that many electrons are there, you can call it as 1 coulomb. Imagine. So charge is given by, charge of electrons is given by 1.6 into 10 power 19 minus 19 coulomb. Okay, this is some information about the. So if minus is there, it is electron. Plus is there, it is proton. That we learn in the chemistry. Okay, clear. So this is the total explanation about the electric current only. So after knowing about electric current, you should know some more terms. I'll explain you on the screen here. Apart from this, so after knowing electric current, and here only will continue. So after electric current, we get the electric potential, second word term. Electric current is the one, right? Second one is electric potential. So generally denoted by E or V, sometimes E, sometimes V, depends. So what is potential? You know, potential is nothing but capacity, ability, tendency. So this is also same, electric potential. In which direction current is flowing? The physical state it is. Physical state indicates the direction of flow of charge. Flow of charge. In which direction charge is flowing, that is the capacity. For example, I am telling simple example. Say this is the earth, right? Earth. We are connected, because you know earth is a big conductor. We are connected the positive charge to earth as well as negative charge also. Right? You can connect the meter here, ammeter, in both cases, or voltmeter. So what we observe is when you connect positive charge to the earth, current flow from positive to earth. Positive to earth direction you can see in the meter. That means earth receives the charge from the positive. When you connect the negative to earth, the current will go upwards, earth to negative. So what you observe here, away from positive towards negative. What is the meaning is always from positive to negative only. So the ability, the potential can be understood by connecting the wire to earth. That is the reason we use the earthing. We use the earthing for our house to avoid the shock. Because if excess of current comes or rain during the rain time, the current is received by the earth. Earth is a very big conductor. It can take any amount of current without affecting our body, because our body also a good conductor. That is the reason earthing is preferable for houses or any other industries. So the potential, the physical state in which direction current is flowing, indicating the physical state is called electric potential. Then potential difference will come. Potential difference, another important term, it is very important. Simply PD, that is we can denote by V. V is equal to W by Q. So what happened here? Current is flowing from positive to negative, right? Correct or not? So to carry from positive to negative, there should be some work done. So that work done is called potential difference. The amount of work done to carry a charge from higher potential to lower potential. Switch on, light glow. Means how it is possible? Because some work is done. So it was some work is done to allow the electron to flow through the cable and reaching the tube light. That work done is called potential difference. That is mathematical formula, the second formula. V is equal to W by Q. That is work by charge. Work by charge. So work, work is measured in joule and charge is measured in coulomb. Simply it is measured in volt. Volt is the unit for the potential difference or potential. And measured by again voltmeter. It's named after the scientist. Scientist name is Volta. So this is another important term. Electric current, electric potential, potential difference. Right. So what is electric current? The rate of flow of charge. The rate of flow of charge is called electric current. Okay. Flow of charge per unit time. Flow of charge per unit time is called current. That is I is equal to Q by T. You can see on the screen. Q by T. I is equal to Q by T, which is mathematically given by charge by time, which is measured in coulomb per second or ampere. Then electric potential. It is a physical state of charged body to indicate the direction of flow of current. It is a physical state only. So whenever the charge is indicating the direction, there is some work done to carry a charge. That work done to carry a charge is called electric potential difference. V is equal to W by Q. Okay. W by Q, which is measured in either joule by coulomb or volt and measured by voltmeter. Above all, how we are getting this current? Suppose switch on you are doing. How light is glowing? From where current is coming? There may be a cell. Just now we have seen the video also. Very important word. Electromotive force. What is electromotive force? Just a minute, sorry. Okay. So electromotive force, that is called EMF. In short form, it is called very important one, EMF. So what I told, we are doing some work. We are doing some work to carry a charge. But from there, that energy is coming for the source. That is called the energy supplied by source. Energy supplied by a source to move a charge. or to do work. Suppose when there is no battery, we cannot operate the remote. There is no battery, you cannot run the radio. Right? So without source of current, you cannot run the AC also. So in our house, for example, if battery is there, battery capacity, if you see cell 1.5 volt, that is capacity of cell. They'll indicate what is that 1.5 is the EMF. So the cell can supply energy of force of 1.5 volt. If you take battery, 3 volts batteries are available, 6 volts, so 9 volts, 12 volts also. So that volt is nothing but the energy which can supply by the source. So why you are using that? To do the work, to move the charge. That is called electromotive force. Simply EMF. The amount of energy supplied by a source to drive a charge or to move a charge from higher potential to lower potential is known as electromotive force. Got? So, clear? So when you move to the next level, so we'll go for next class. But before that, when you learn about the 2 points, 2 important topics we learn, that is about the current, I. Yes, we learn about the what is current, Q by T. Second one is we learn about the voltage also, potential difference, W by Q, right? So there is a relationship between these two are there. What is current and what is voltage or what is potential is the relationship between V and I. The relation, they are not separate. Relation between V and I is there, is given by very, very important law called Ohm's law. So we'll come across next class, but just I'm giving the introduction for you. As per the Ohm's law, V is directly proportional to I. Means whenever you are increasing the current, voltage also increases. Increase of current increases, voltage also increases. If increases the ampere of current, voltage of volts also increases directly. That we can see in the circuit also. By arranging the circuit, we can clearly observe. When you increase the battery, when you increase the power supply, this also increases. So to remove this symbol, ampere is one constant, IR. So very, very important formula in physics. Again, third formula in electricity. First one is I is equal to Q by T. Second one is W by Q. And third one is V is equal to IR. Is the Ohm's law, where R is the constant called resistance, which is very important to control the flow of electrons. See, the symbol is, we have seen just on video. This is like speed breakers. Why you are using speed breakers? To control the speed. Similarly, in every electric circuit, resistance is used to control the flow of electrons. So this resistance is measured in units called ohm, name of the scientist with the symbol of this. So current unit is ampere. So voltage unit is volt and resistance unit is ohm. We learn 3 formulas, 3 units. Right? Clear all of you? Very, very important this one. So this entire chapter, whatever the third and fourth synopsis, includes the electric circuits followed by these important terms like electric current, electric potential, potential difference, electromotive force, and finally the Ohm's law. Clear? So the Ohm's law further explanation you can come across in the next class. When you go to the 7th or 8th standard, come across the complete explanation about what is the Ohm's law, what are the conditions for the Ohm's law, where it is applicable. Okay, you can see everything when you go to the higher classes. But right now, we are done with the synopsis 4 also. So when we meet in the next class, that will be on Saturday, we'll have the discuss about some new topic or some further explanation about the electric current, which is your test 6 syllabus, right? So go through the materials whenever you get the time in the school or at home, so that you can get prepared for the examination, which is having on 30th December. Very big time is there. In meantime, you can note down the home task, homework as Name and explain the components of electric circuit. Component of electric circuits are sources, bulb, that is component, that is electric consumers. Source is the cell or battery. Explanation is there. Then bulb, switch, wire. These are the four important components. All these four explanations is given in the material. You can go through and write the details in the notebook. Take the signatures from your parents as well as from the teachers also, right? So that's all for today. So thank you very much, all of you. Have a wonderful day. Thank you.